Wait, so why did you bring these?
I'm gonna drop these off 4 stories of this building, and we're gonna film if they hit the ground at different times. You've probably seen a demo like this before. Famously, they did it on the moon, and as you saw, the hammer and the feather hit the ground at the same time. Interestingly, that's not the speed of gravity, that's the acceleration due to gravity, which is related to the force of gravity itself, sure, but this is just to kind of get the basics of what gravity does, and then we'll talk about how fast it moves. I'm drawing faces on them. I thought that would help us and the viewer, you guys, really relate to these characters. I'm gonna name this one Wilson. Bye-bye, Wilson.
Now, I really thought they were going to land at the same time.
So, the small difference in how fast and when they hit the ground was due to air resistance. In a vacuum, I can show with some simple math that the force due to gravity is equal to the gravitational constant times the mass of the object times the mass of the Earth, all over the distance between them squared. We also know that force is equal to mass times acceleration. Because they're equal, we can put them on opposite sides of this equation, and we notice that the mass cancels out. It has nothing to do with the mass of the object. It is important to note that this isn't the speed of gravity, it's the acceleration due to gravity.
This is one of my favorite demos, and it's just this giant sheet of Lego, which is the same stuff they make swimsuits out of. It's really stretchy, and when you take a mass and just place it on it, it'll warp. Just like gravity warps space and time itself. And like Einstein said, when you take 2 masses and place them on it at the same time, they'll pull themselves together, just like gravity says they should. So let's say you take something big, like the sun, or this 5-pound weight, and place it on it. It'll warp it a lot. And if you take something small, like the Earth, this golf ball, and actually throw it into orbit around it, which is neat and quite beautiful. So the question becomes, how fast is gravity? And the speed of gravity isn't how fast things get pulled together. I mean, that can change depending on the mass of the object or how big they are. The speed of gravity is actually how fast this curvature in space and time propagates throughout the universe. A great example is it takes about 8 or 9 minutes from light from the sun to get to the Earth. And the speed of light is the fastest thing in the universe. So let's say you remove the sun from that system, the Earth will actually still orbit for 8 or 9 minutes because it doesn't realize the gravity from the sun is gone until it has the time to propagate those hundreds of thousands of miles.